Does the tool make the man, or does the man make the tool? Then again, do we really care? Leave your comments below. I'd love to hear your thoughts. But in this episode, we're going to add another tool to our disposal. In my previous video, we showed how we could use Ghidra to find an AES key that used for both encryption and decryption in an IoT device. Well, in this video, we're going to use Binary Ninja to expand our repertoire of tools. So sit back, relax, and enjoy. Thanks. Welcome back. I already have Binary Ninja opened and ready to go. Now note that I've already set up Binary Ninja to my selection or my preference style, so just know that you're able to do that as well. But I have in my recent files directory here libcmm.so. That is the file that we found in our first hacking exercise all the way back when we used binwalk to open up the firmware, extract the firmware, did a grep for decrypt or crypt, and we found this shared object file that was of interest. Now, in my previous video, we used Ghidra and we found AES, the key that can be used for encryption and decryption. So let's see how easy it is in this next tool, in our Binary Ninja. And so as you see here, as I mentioned before, I have a view that is separated because I love to see both the disassembly and the linear view, the high level intermediate view. You can also use sudo C, sudo rust, medium, etc. So pretty much anything to fit how you'd like to view. Here, I want to go ahead and take a look and see if we can't find that decrypt functionality that we found. And so immediately we find a bunch of functions of interest. Now eventually we can go and take a look and taking a look and clicking on each of these and get a feel for what it is. So let's go ahead and take a look at all these different items here, and here's actually the item that is of interest. So let me move this over a little bit. But again, you can go through and take a look at all these different pieces here, and you see the different addresses that they're identified at. And again, we have the disassembly view and the high-level intermediate language view. Decrypt file takes 4 different arguments, it looks like, or this is what Binary Ninja is identified. We see that similar memcpy that we looked at before. So we copy whatever's at this data location into this destination of the var 28. We have the comparison, buffer exceeded, decrypt buffer size. So we have an error message, also an additional error message, and we just have a bunch of different functionality that goes through and takes a look at it. But what caught my eye and what I always like to take a look at is, okay, what's getting copied over here? So we're going to go ahead and click on this, and we see that what we have down here is it brings us to this data section where the location of the address is, and similar to what we've had before, this is the actual AES key that was used to both encrypt and decrypt the configuration files that we found in the extracted firmware. So of course we make note of that in our notebook, or however we take notes, that the key is 478D850F F9E3D2CB. And I'm going to again show you walk you through how we can use this key to decrypt and see the contents of those configuration files. So stick around. Alright, let's decrypt that file again. As you see, I have those encrypted files already pulled up or saved. So let's go ahead and cat the configuration or XML file. And as we can see, gibberish, or appears to be gibberish, and that's because it's been encrypted. Let's take a look at the other one, the reduced data model XML. Again, gibberish, something that we can't really recognize because we apparently would need the key to be able to see that. So let's go ahead and clear that again. So what we're going to use is we're going to use OpenSSL, similar to what we did in the last one, actually the same command. And I'm going to just copy and paste it into here. Got a little excited there and accidentally copied that twice, so apologies for that. And actually, let me just go ahead and clear that again. Alright, so we have the command that's similar. We have, let me explain it to you, the OpenSSL, which then we have ENC, which is going to basically invokes the encryption decryption tool. TACD specifies that we want decryption mode. TAC DES-ECB specifies that the encryption algorithm and mode is the DES, which stands for the Data Encryption Standard in ECB, which is Electronic Codebook Mode. Notepad, or TAC notepad, meaning this disables the padding on that. And then we have that key, which is that hard-coded key that we've just found using Binary Ninja in the Decrypt functionality. And TAC in is specifies the input file, which is the default config. So let's go ahead and hit enter here, and magically, or because we found the hard-coded key, we're able to go ahead and read this in normal fashion. So we are able to, because of the statically encoded key, we are able to go ahead and actually decrypt that, because this is the same key that was used to encrypt it. So let's try that on the reduced model and data model. And again, success, because that key was used to both since it's AES, you use it to encrypt and decrypt. It's the same key, so we see why it's a bad reason to hard code AES keys in files of your firmware. Thanks, and look forward to seeing you in the next video.